Hello everyone and welcome to another video. Yet again we're working on the compiler. In the previous video we implemented or we fixed a bug with the previously implemented arithmetics, adding numbers together. So now we can add multiple numbers together. And we can see the result here. However, there was a problem with doing something like this. X int is equal to 10 plus 10 and print x. We're even getting a sig fault in this case. And I think printing integers in general were broken. Yeah, if they are in a variable, I think we can do that. Oh, sorry, I should have used print I. So we can print integers, sorry. What if I print that variable? That doesn't work. We're getting a 0. So it's broken when we store them in variables. And there's a simple fix for it, because right here I'm moving them into minus 16 ESP. Should actually be EBP. And that will not exactly solve the problem. Because we're still getting 10. But it will solve the problem where we cannot print variable integers anymore. So in our front end, we have this comment here. Here is where we're doing the trickery, which is wrong. We should do EBP. So now we can print variable numbers again. However, we're not getting 20 here, which is the expected result. Can I still print it as a normal like that? Yeah, cool. Can I print 10 plus 10 like that? 20. So that works. There's only a problem when we're printing it and it's inside of a variable, I suppose. Yeah. So why do we have a problem with that? Push EX. So we're pushing EX. Right. Oh, I think I have a pretty simple solution to this problem actually. So when we're doing this bin up thing, we also want to do this move byte thing. And this will probably be different for other kind of data types, but right now we only have, this only works for, we only have integers here right now. So I think it's perfectly fine to just assume that an integer is being used right now. So now, actually, that was not what I wanted to do. I wanted to move byte EX into CL. Sig fault. There we go. So we actually want to do ESP here. And we're actually doing that type of thing after we're encountering that integer, or when we're encounter integers in general, we're moving that address into CL. But I wonder if we can sort of reuse that maybe. So what have we pushed into? Yeah. I think it's fine to reuse it. So that should solve it. 20, cool. What if I do 20 plus 5? 25. Cool. So it seems to work. Now what I want to be able to do is to subtract numbers. So we're going to copy arithmetic add, and we're going to have an arith sub. So first of all, we're going to have to implement the subtraction symbol inside of the lexer, and first we're going to have to go to the token and define this. So we're going to have a token minus, and we're just going to copy this minus. Cool. And for our test case, maybe we will do 16 minus 6 maybe. And if we run that now, we're getting an unexpected token here because the parser doesn't know what to do with it. So when we're doing the plus, we also want to check for if it's a minus here in the parse term method. Yeah. Parser token type is equal to token minus. Now it actually compiles, but we're going to get some undefined results here, or undefined behavior, because in our front end, when we're doing this, we're not checking what type of operation this is. So basically we can do a if AST type AST op is equal to token plus, and then we're going to do this, of course. Otherwise, we're going to do a sub. I think that's it. And we need to include token on age. That was not correct. So first of all, are we entering this thing? Yes, we are. And what does the assembly look like? We're pushing 16, we're pushing 6, and we're moving them in there, and we're subtracting ESP from EX, which now, so basically, we're subtracting 16 from 6. So it's in reverse, basically. So we need to do these in the reversed order, I suppose. I think we can just do well, how are we going to reverse this? Well, one way of doing it is simply to do these two in the opposite order. And that will work in both of the situations. So that works. Cool. So our add is supposed to give us a 25. And we're not getting a 25. Why are we getting a 5? So maybe this wasn't a good idea. Wait, this add thing is also broken at the moment. Or what is this thing that's printing out? try and get it. How did this happen? Worked. What did I break here? Okay, so that's not happening for some reason. Interesting. Front end. That's very interesting. What? Oh. There we go. So arith add now gives us 25, which was expected. Cool. So maybe after all I can switch this out. 25, cool. And sub 10. So that works. So arith add is supposed to give us 25. And sub is supposed to give us 10, which we got. So it seems to be working. What if we want to remove, let's say we remove one more, just to see that we can remove multiples. 11. Oh, I see what's happening. So it's actually removing, it's removing 1 from 6 first before it does this. So it's going to remove 5 from this. So the way we would solve it later is to implement, you know, these type of things. But right now, it's not possible to do that. But that will solve our problem later. But anyway, I think that's it for this video. Thank you for watching.